Okay, so on Thursday and Friday of this week, the next two lessons are going to be about the inverse trigonometric functions. So our first lesson is going to be about inverse sine and inverse cosine, and our next lesson will introduce inverse tangent. But before we do that, I need to make sure that you guys have an understanding of the graph of f of x equals tangent of x. There really is no good way to do this. I think it needs to be explained in some sense. So that's why I think this would be appropriate for a video lesson. So let's just think for a second. If I wanted to graph any function, one way you can always start is just by plugging in some points. So let's say I plug in 0. Hold on 1 second. What? Okay, sorry about that. My smartboard was totally misaligned and I didn't realize. Okay, back to math. So let's say I just plug in 0 degree or 0 radians or 0 degrees. 0 is not in a quadrant, so I'm not going to fill that out. Well, tangent is sine over cosine. Sine of 0 is 0. Cosine of 0 is 1. And so the tangent at 0 is 0. That was easy. Okay. Now, let's think about what happens as we grow. So here's my little animation of this. So right now, as we can see, we are at 0 degrees and we have the green dot at 0. So now what I want to do is actually take you through some angles. If we remember correctly, tangent is literally the length of the tangent segment that's going to be drawn in yellow. So as my graph increases, so for example, if I get to about 30 degrees, my tangent length is 0.577. If you remember, a tangent touches the circle once. That's what's going on with your yellow segment. And if you remember correctly, if I extend this out, tangent is just opposite over adjacent, and the adjacent is always 1 in this case because we're on the unit circle. So essentially what happens is that this golden length is the length of tangent. And by the way, just to make sure we understand, tangent of 30 degrees is 1 over root 3, and that's your 0.577. Okay, so now I can actually graph that on my graph. So I'll go back to my graph, and I can say, well, at 30 degrees, which is pi over 6 radians, and we're in the first quadrant, my tangent of x is 1 over root 3, which is about 0.577. All right, so just so we can fill this graph in, pi over 4 is 45 degrees. So 30 degrees is right about here. So I'm at a little bit above 0.5. All right, I'm going to go to pi over 4, or 45 degrees. And remember, tangent of 45 is easy. Tangent of 45 is sine of 45 over cosine of 45. And that is just 1. So if I go back to my animation, and I make this theta become about 45 degrees, we'll see that happen. Whoops. There's 45. It's a perfect 1 unit. And as you can see, the blue graph is my tangent graph. It's starting to grow pretty quickly at this point. So I want to plot my point. My 45-degree point is 1. Okay. Now, as the angle gets bigger, as that angle, my angle was at 0, now it's at 45. As my angle gets bigger, my tangent segment continues to grow. So it continues to grow. My tangent segment continues to grow. And at 60 degrees, we know what the tangent of 60 degrees is. So we're still in quadrant 1 here. Pi over 3 is 60 degrees. The tangent of pi over 3, or 60 degrees, is the reciprocal of the tangent of 30. So that's radical 3, which is 1.73 or so. So when I get to 60 degrees, I can plot a 1.7. So now you can see this graph that I'm going to start to kind of trace out here. I'll trace it in crayon here for a second, so you can kind of see this graph is growing. That's going to be my tangent graph. Now, what I'm interested in is what actually happens past 60 degrees, because at that point, we don't have too many special angles. So if I look, what's happening past 60 degrees, as I get higher, as my angle gets higher, my angle gets more and more and more steep. My tangent segment, I'm not even on the paper right now. My tangent segment grows and grows and grows. So if I look, if I went from 54 to 57 to 60, whoops, to 75 degrees or 69 or 75 degrees, what's happening is my tangent segment, the tangent line segment, is growing. And as I get closer and closer to 90 degrees, the tangent segment just keeps growing and growing and growing. Another way to see this is on the calculator. So for example, I'm just going to be in, I'm in degree mode. The tangent of 75, okay, enter, is a pretty big number. Well, it's big in the sense of the relative terms. It's 3.73. All right, now if I start increasing that angle even more, so let's say I wanted a tangent of 81. Hope that you could see as I increase that angle, as I increase that angle to keep going and going and going. Sorry, I have to get to the computer to do this. As I increase that angle to keep kind of going and going and going here, as we increase the angle, that tangent segment just gets higher and higher and higher. It gets off the page. So for example, if I went to 81 degrees, okay, 81, my tangent is going to be even higher. It's going to be 6. And as I get closer and closer to 90 degrees, my tangent just keeps growing. So for example, if I took tangent of 88 degrees, I'm at 28. Because at 88 degrees or at 87 degrees, I'm still climbing. So if you take a look, here's 87 degrees. My tangent segment is so long, again, it's going to meet up. These guys are going to meet up, and this red length here is going to be my length of my tangent segment. So as I get closer and closer, let's say I take tan of 89, I get 57. Tan of 89.9, I get 572. Tan of 89.99999, I get 570 or 5,729,577. The closer I get to 90 degrees, the higher this value is going to get. So just if you think about this for a second, if I had a very steep angle, my tangent segment is going to be very long. So if I have a pretty steep angle here, this is going to be long. And as I get closer and closer to 90 degrees, this thing just keeps growing and growing and growing off the page. This tangent segment, I can't even fit it on here at that particular angle I chose. So if I am looking at 90 degrees, so here's my tangent segment. It's going to go up this way. If I'm looking at 90 degrees, the tangent segment will never meet this ray. So it's almost like saying tangent of 90 degrees is sort of like infinity. If you think about this in terms of sine over cosine, we know that sine of 90 over cosine of 90, we know sine of 90 is 1 and cosine of 90 is 0. And that's where we get this undefined bit here, that the tangent of 90 is undefined. What's really happening is that the tangent of 90 is so big that we can't define it. So for example, if you had 1 divided by a very, very tiny number close to 0, you would get a big number. And that's what's happening. That's another reason to explain why this tangent thing is blowing up. So what happens on this graph is we get what's known as a vertical asymptote. And we talked about this in terms of ln. ln has a vertical asymptote. So what's going to happen is as we get closer to pi over 2, so let me put a couple of angles in here. So at, let's do tan of, I don't know, doesn't really matter, tan of 81, say. Okay, tan of 81 was 6, so I'll put 81 degrees here. I got 6.31. So as I get closer and closer to pi over 2, I'm getting off the chart here. And what's going to happen to my graph is that I'm going to have what's called a vertical asymptote, meaning as I get closer and closer to 90 degrees, this graph goes way up as I get closer and closer to 90 degrees. And the way we represent that on the graph is we draw a dotted line at pi over 2 or 90 degrees, and we allow the function to kind of, we allow the function to climb to that value. So we allow the function to climb to that height, and it keeps going and going and going. And notice there's no meeting between the purple and the green. So the green is a vertical asymptote. The equation would be x equals pi over 2. And as we know, at pi over 2, tangent is undefined. Okay. Now, as we do the second quadrant, I want you to keep in mind that your tangent values are negative. So as we do this for the second quadrant, the tangent values are negative. So if I think about what's happening at, say, 91 degrees, okay, or 90.1 degrees, let's do that. I'm going to go a little past 90. Tangent of 90.1 is negative huge. And as I get away from 90, so I'll go to 91, it's still negative and still huge, but it's not quite as huge. So what's happening is, if I think of it like this, if I have, say, 90.1 degrees, my tangent is negative huge. And as I get away from that 90 degrees, so if I had tangent of 91, I get 57, negative 57 approximately. Tangent of 92, for example, let's just slowly get away from that asymptote. It's only negative 28. So let's go to, like, say, tangent of 100. Okay? Tangent of 100 is negative 5. So what's going to happen here is, if I think about this, 90.1 is really close to 90, and I'm going to get a very negative number. 91 is really close to 90, I'm going to get a negative number. 92 is really close to 90, I'm going to get a negative. But what's going to happen is those negatives are going to start to slowly get more or less and less negative and more positive. And that's why I'm drawing these little dots down here. So as I get away from the asymptote, my graph is going to start to kind of creep back up. Okay. Now, if we get into the second quadrant, I can start thinking about, for example, 120 degrees, which has a reference angle of 60. Well, tangent of 60 was radical 3. But now it's going to be negative because we're in the second quadrant. So this is negative 1.73. So tangent of 120 is about 30 degrees, well, it is 30 degrees from 90. It's only negative 1.73. So now my graph looks something like this. So at this point here, we have 135, which would be 3 pi over 4. I'm looking at a reference angle of 45, and I know my tangent of 45 is 1. So the tangent of 135 is negative 1. So now, smack here, actually I should really move this 120 over a bit. And at 135, we're at negative 1. Okay? And I hope that you're starting to see, if I were to try to connect these dots, you would almost get a very similar curve to the way you had our first purple curve. Okay, so I can still work in the second quadrant. I can go to 150 degrees. That has a reference angle of 30. So I go back to my 30, and I say, oh, look, 1 over radical 3, well, this is going to be negative 1 over radical 3, or negative 0.577. So at 150 degrees, I'm at a little bit less than negative 0.5. Okay. Now, these are all in quadrant 2. That's where tangent is negative. And at 180 degrees, all right, at 180 degrees, tangent is sine over cosine. So we're back to where we started at 0. The sine of 180 is 0, and cosine of 180 is negative 1. So we have 0 over negative 1, which is 0. And so we're back. If we're taking a look at this, we're back. Move this a bit over. And now we can trace out that other cycle here. I'll trace it out in blue. Okay. Now, if I think about what's coming up next, I have my third quadrant coming up next. Third quadrant sine and cosine, third quadrant tangent is positive. So I'm looking at my first quadrant simply being repeated here in my third quadrant. Hope that makes sense to people. In the third quadrant, tangent is positive. So everything just gets repeated. So what I'm going to do is I'm going to take, sorry about that, I'm just going to take the first quadrant graph, which is this guy, and I'm just going to clone him. Because guess what? The third quadrant follows exactly from the first quadrant when you're dealing with tangent. So here's my graph, and guess what? At 3 pi over 2 or 270, I'm also going to get an asymptote. So I'm just going to copy over that asymptote too. So here's my asymptote. Whoops. Sorry about that. Let me do that again. Here's my asymptote. And I'm going to get that asymptote at 3 pi over 2. And then, of course, if you're thinking fourth quadrant, the pattern's going to repeat itself again, because fourth quadrant and second quadrant match. Get rid of this line. I didn't mean to put it there. So fourth quadrant and second quadrant match. So I'm going to take my blue graph and clone it, and that's going to be my fourth quadrant picture. And this cycle is going to happen over and over and over again. So this is the graph. This is the graph of tangent of x from 0 to 2 pi. There are going to be infinitely many asymptotes, and they're going to be at multiples of 90 and 270. And your graph is going to have this shape to it. So on the back, I kind of laid this out so that you can get a few more cycles in. So you might want to do this before I do it, just to see what you've retained from this video. And I know this is a tough graph, so on Friday I will definitely answer any questions about it. So as we discussed, there are asymptotes at every multiple, at 90 and 270, and therefore there will be asymptotes at negative 90 and negative 270. Okay, so you can take, basically, if you start at 90, keep adding 180s and you'll get asymptotes. So again, I'm in the first quadrant here, and my tangent is positive. And I'm going to start at 0, and I'm going to go up to the asymptote. Then in the second quadrant, which is from pi over 2 to pi, my graph is negative. My tangent is negative, so I'm going to come up from the asymptote and meet my point at 0. And then I'm going to repeat that again. I'm going to repeat that same cycle, because the third quadrant, in the third quadrant, tangent is positive. And again, in the fourth quadrant, tangent is negative. So I'm going to repeat that second quadrant cycle again. And this will go on forever and ever and ever. I can keep drawing. And I hope that you see, I'm going to simply take that pattern and extend it across. So at every multiple of 180 degrees, I have a 0 or a root. So every multiple of 180, I'm going to put smileys on them. If I could find the smileys. It's having such a great day at the smartboard here. Where's my creative pen? Here it is. Okay, here are my smileys. At every multiple of 180, I have a 0. Okay? Every multiple of 180, I have a 0. And at 90 and 270, we have an asymptote. So I'm going to draw the same pattern over and over and over again. And this is the graph of tangent. And again, there's not much to this graph other than what you're seeing. Now, I did want to talk about the domain and the range a bit. So I'm just going to zoom out here a little bit. I did want to talk about the domain and the range. So the domain, well, tangent is defined. So tangent is defined for all x's except where we have the asymptotes. So the domain of tangent is all x's except, if I think about this, I have my 90 and the 270. And I can add any multiple of 180 degrees. In fact, what you really could say is you could consolidate this and say, if I look at 90, that's where I have my first asymptote. The next asymptote is 180 degrees later. The one behind it is 180 degrees behind it, and so on and so forth. So what you can say is the domain of tangent is all x's except 90 plus 180k, where k is an integer. If you wanted to phrase this in radians, you can say all x's except pi over 2 plus pi k, where k is an integer. Basically, what I'm saying is that if you start with 90, add any multiple of 180, and you'll get you'll get a number who's not in the domain. The range, on the other hand, if I look even at just one cycle of this, so I'll take this one basic cycle that I have, that graph encompasses every y value. There is no y value that's missed, because I can make tangent as small or as big as I want to by making sure that angle is at the appropriate range. So the range is all real numbers. What we're going to do on Friday is we're going to define what's known as the inverse tangent function and calculate values of inverse tangent. But before we do that, I definitely want you to have an idea of what the graph of y equals tangent of x looks like. By the way, just as a side note, you can graph this on your calculator. So on your calculator, if I could plug in y equals tangent of x, I'm in degree mode, okay? I'm in degree mode, and you can do this in radian mode, it's just fine. My window, I'm going to make my window negative 360 to 360. That's my x min and max. And my y min and max, I could make them, I'll make that say negative 4 to 4. Really, you could even make them higher, and you'll get the graph that we just constructed. And you'll actually see, you can almost draw on your own asymptotes. And again, this is a hard graph to sort of understand as an activity, I think, and that's why I think it's better off explained. So that's why we did the video lesson, and I try to show you multiple ways to kind of view this graph. And that's what the graph of tangent looks like. All right, so just make sure you have your video complete, the worksheet complete. On Friday, we'll answer any questions about that you had from the video. All right, thanks, guys.